Okay, welcome back everyone. This is another pfSense video. We're going to touch on a couple other things that I didn't really get into in the last video. And the last pfSense video that I did, I think ended up being around 2.5 to 3 hours, somewhere in that range. So I'm going to try to keep this one a little bit shorter, actually a lot shorter, because we're just going to do a couple little things with VLANs and maybe the Avahi Bonjour Zeroconf reflection and proxy, which is pretty cool if you're dealing with Bonjour devices and multiple networks or multiple VLANs. And I still have the pfSense machine, the install that I did in the last pfSense video where we installed it with VirtualBox. And so I'm going to continue on. As you see on my screen right here, this is the same, what I'm logged into right now is the same pfSense install that we did in the last video, and I haven't done anything to it. So let's go ahead and get started. I think I'm going to touch on VLANs first and how pfSense, how the interface deals with VLANs, and how the Bonjour proxy and I guess reflection service would work with VLANs. And then I'm also going to go back into the VirtualBox config. And if you'll remember from the last video, when we did this pfSense install in VirtualBox, we only configured two hardware network interfaces. So we basically had the LAN side and the WAN side. And for a firewall, those are that's the minimum that you have to have. You have to have an external and an internal. The cool thing is, so you have the two interface minimum, but there's really no maximum as far as the number of interfaces you can have. You can have more external facing interfaces if you have more than one WAN connection, and you can also have multiple LAN side interfaces for different networks, different subnets, and you can have different VLANs on different physical hardware network interfaces. You can have network interfaces that don't have any VLANs. It's totally up to the network engineer and whoever's designing the network and designing the system as to what hardware is required, what speeds are required, and so on and so on. So let's go ahead and take a look at how you would create another network interface on the LAN side if you only had one network adapter designated for the internal network, which is our case right now. So if we go to interfaces and then click on assign, you'll see that we have the WAN and the LAN, and this is a physical interface and this is a physical interface. Now mind you, this is pfSense running in a VirtualBox, so in reality these adapters don't exist. Okay, so just keep that in mind, that in reality these are actually connected to the Wi-Fi adapter on this MacBook. But for our purposes in VirtualBox, pfSense believes that there are two actual physical network interfaces. So, and I believe that in a more production environment, obviously no one's going to want to run, pfSense on a MacBook. That would be a terrible thing to do, and try to keep it reliable. So, and I would say in most cases, you're going to actually have pfSense installed on real hardware. You're going to have a bare metal install. You're not going to be installing this on a hypervisor of any sort. That's not to say you can't, but I think you'll get better performance if you install on bare metal. So, as far as this server is concerned, pfSense is installed on a bare metal server that has two network interface cards. And so we have WAN and LAN. And let's say that we want to sort of provide a secondary internal network. Maybe that is a printer network, maybe it's a guest network. Whatever it is, we want to have a secondary LAN network, but we're out of network cards. We don't have a physical port to plug in this secondary network, so what do? We can come into here and create a VLAN by clicking VLANs, click Add, and then the first thing you see here is the parent interface. And so basically what this is what physical of the two that you have to choose from, what network do you want this, what hardware do you want this network to reside on? Are you trying to create a WAN network or an internal network? And obviously in our case right now, we are trying to create a secondary LAN network, another VLAN. And then you're asked to specify the VLAN tag, and you have to put this in. The VLAN tag is required. This is what's going to define what the VLAN number actually is. And you see here, they very politely tell you that the VLAN tag can be between 1 and 4094. So it's totally up to you to pick any of these numbers. It can be anything you want. Now, when you're picking a VLAN number, I believe that it's a good practice to try to pick a number that might mean something. Try to pick something that would maybe go along with the network that you're about to create. So we know that our untagged network on the LAN side, our regular network that we created in the last video, was 10.0.0.0/24. So now let's say our guest network is going to be 10.0.100.0/24. That makes sense, right? Or it could be 10.0.50.0/24. It can be anything we want it to be. So let's say we plan on making the guest network 10.0.100.0. Well, maybe we should make our VLAN tag 100, because that would sort of go along with this new network. Now, you may not always be able to make the VLANs match the subnet like that, but if you can, I believe it's good practice to sort of try to get it close. And like I said, you may be in a situation where you just need to know that VLAN 251 is what it is, and in those situations there's not a lot you can do. But since we're designing this from the ground up, let's go ahead and make this VLAN 100, and we'll plan on creating the new network of 10.0.100.0. All right, VLAN priority, this is where you could actually do QoS. You could say, QoS, by the way, is quality of service. You could say, between 0 and 7, the priority. Obviously, the lower the number, the higher the priority is. If you have a VLAN priority of 7, then that's going to be treated the lowest. So let's say that this new network is going to be a VoIP network. We could actually say, hey, VoIP is something that it's really crucial that these packets are treated with the highest priority. And I actually may have, let me click on this right here. I may have gotten that wrong as far as, oh, I have no internet connection. I may have gotten that wrong as far as the 0 and 7 and pfSense's 802.1q VLAN priority. I'm not sure if I'm 100% right on that. Anyway, it's one or the other. Either 0 is lowest priority and 7 is highest priority, or 0 is highest priority and 7 is lowest priority. So if you wanted to really make sure that this new network and everything that was tagged with a 100, if you wanted to make sure that it was treated with the utmost, let's call it utmost respect, and every time this packet came through, the firewall said, hey, I'm busy doing other stuff, but for you, I'll go ahead and pause the other traffic and let you come through. That would prevent situations where VoIP calls are staticky or choppy or maybe even dropped altogether because the same internet connection is being used for downloading, torrents, or downloading large files, or a lot of gaming is going on. Um, Obviously, if someone is downloading a torrent, that traffic is less, less of a priority than the VoIP traffic, where people will really notice if some of those frames get dropped. So we will make this 0 to, I believe, make that highest priority. You may want to go to the pfSense website, double check on their VLAN priority, or actually, if you click this question mark, you'll actually, I'm not sure. Hold on just a second. I should have internet connection here. What is going on? Let's go back here. It's not making any sense why that didn't work. There's no internet disconnected. Dashboard. Well, anyway, if you have a working internet connection, then when you click the little question mark right here, you should get taken to a little page that will describe more about it. And I know for a fact that if you go into the VLAN assignment right here and click this question mark, I know that they will explain how their numbering system goes as far as VLAN priority. So like I said, we'll make this LAN, we'll make the VLAN tag 100 and the priority 0, which I think means of the highest, because between 0 and 7. And in my thinking, that's what I think, is that 0 would be the highest. So let's see, we can add a description to this, and we can say guest network VLAN 100, and that way we know what we're doing. We can say QoS 0. All right, so then at a glance we can take a look at this network interface and go, oh, that's our guest VLAN, and it's VLAN 100 and its QoS is 0. We don't have to click into the interface to actually view this information. So we'll hit save, and now we've created a VLAN network on the EM1, which is our LAN interface. And so now, if we go to interface assignments, you'll actually see that as far as pfSense is concerned, we have 3 network adapters. We have 3 interfaces now. Because it's saying available networks that we can choose from are right here, and there's the one that we just created. So if I go back to VLANs and I say, oh, you know what, I also want another network on VLAN 200, description other network VLAN 200 QoS 0, save. Oh, actually, you know what? I didn't put in 0 here. So this is actually going to be treated just like an unprioritized network. So we'll actually just take this out. Okay, so guest network VLAN 100, and now we've got VLAN 200. So if I go back to interface assignments, then I can say that I want to assign VLAN 200. So as you can see, the more VLANs you create, the more interfaces you'll have to choose from when you want to actually come into pfSense and create a new interface that pfSense can operate on. And what does the interface mean? What can you do once you assign an interface to a network port? Well, once you assign an interface to a network port, like I'm going to show you, then you can go in and set things like an IP address for that interface and a subnet mask and lots of other options, just like we did on the WAN and LAN. So let me go ahead and show you that now. Let's start with VLAN 100. We will add that, and you can see it. The interface name becomes OPT1. That's just by default. And we'll come over here and we'll go ahead and add our second network that we did. So we have OPT1 and OPT2. Now, if I click on OPT1, you can see the default is to not go ahead and enable the interface, which makes sense because it's not configured yet, and that would be pretty dumb to go ahead and enable an interface that you haven't configured. So description. This was our guest network. And for the description, I think it's probably a good idea to sort of leave it short and sweet, like maybe just guest network. And we'll say that this is an IPv4. You could, come in here and also assign an IPv6 IP address to this interface as well. You can specify a MAC address, MTU, MSS, speed. So we're going to go ahead and click Enable, Guest Network, Static IP Address, and now we can come down here and actually define the static IP address. So we said we want to do 10.0.100 as our network. So I will assign this this interface an IP address of 10.0.100.1. That'll be the IP address of this interface. And so what that means is any device that is going to be on this network will use 10.0.100.1 as its gateway. We can make this anything. We can make it, 200. And then every device that wanted to use this network and have a gateway would use 10.0.100.200. I like to use 1 just because. Some people they like to see 254 as the interface IP address. I just happen to prefer 1. It can be whatever you want. This will be a /32 because we're assigning this specific IP address. Let's see. Since it's a local connection, we will not specify an upstream gateway. If this was a WAN connection, then you probably would want to come in here and provide a gateway. And we're going to leave these two boxes unchecked since our WAN is actually an internal network. So, actually, this needs to be a 24. This will be what determines what the subnet is. Okay. So, and this could be anything. This could be 16, which means that that would be a large subnet. But that means that anything in the 10.0, dot whatever would be included in this subnet. And that's probably not a good idea for our purposes right now. So we'll make this a /24, and basically when you see a /24, what that means is that this group, and this group, everything except for the last octet here are going to be, outside of the subnet. It's not going to be until we get to here, this last group, that that will be included in our subnet. Okay. I believe that's it. you may need to, under certain circumstances, you may need to come in and actually set the speed in the duplex, but we don't have that issue here. So, and like I said, if you're going to use IPv6, you could actually do IPv4 and IPv6 at the same time. It doesn't have to be one or the other. These can do both. And I think it's kind of cool that you can do a static IPv4 or DHCP IPv4. And at the same time, you can, on IPv6, you can do static or DHCP on that as well. So you could say, I want IPv6 to grab an address from DHCP, but on IPv4, I know that I always want this address associated. So that's pretty cool. If we come over here and save, and then apply, and then we go back to assign, then you'll see we have WAN, LAN, guest network. And now, if we go to firewall and view the rules, you'll see that we also have a new interface to define rules on, because we may want the LAN, let's say we want the LAN network to be able to go out to the internet on any port whatsoever and everything is great. Or we may want to assign the guest network and let them only go out on certain ports. So it's really, really cool that you can start to build out your network with multiple interfaces, multiple networks, and really configure them as much as you want. So, we can come here and I'll just show you this one more time. Like I said, maybe this will be the printer network, and we'll say static IPv4. And we made this network, we called it VLAN 200, so we'll make this 200.1. And we'll make it a /24 as well. It just makes sense. You could always go smaller if you wanted. If you wanted a smaller network, you wanted fewer addresses, you could also, you could bump this up even higher than a 24 if you wanted to. But if you don't know what I'm doing when I'm selecting a 16 or a 24 or 32, if you're not sure, then I highly recommend that you take a quick guide on networking and IP addressing, and that would really explain a lot. Because if you don't know what I'm doing here, you're probably kind of lost as far as what is he, why is he picking a /24? A quick little hint, a /24 basically equals 255.255.255.0. And I'm sure you've seen that before. That's I guess the more typical subnet mask that people see. So anyway, 255.255.255.0 is a /24. And so I've done this 10.0.200.1. It's always a good idea to go back and check your work, make sure you've got it enabled, make sure you've called it what you actually want to call it. You've got IPv4 selected, if that's what you want. Make sure you have the right IP, the right subnet, and everything looks good, so we'll save that. It's always a good idea to take an extra 5 seconds and just double check things, because if you're doing this a lot, constantly changing things and updating things throughout the day, and you don't double check your work, then you could really cause a problem that's kind of hard to find. All right, so let's go back. You can see we've got basically 4 network interfaces on this computer or on this server that only has 2 physical interfaces, and we started with 2 interfaces, and now we're up to 4. So that is the power of creating VLANs, is that you can, without purchasing more hardware or running more network cable or rebuilding the entire infrastructure, you can run multiple networks on the same hardware and the same physical media. So I guess we'll go ahead now and show how the Avahi proxy can be installed. It's a package that's available in the pfSense interface, which is pretty cool. It makes it nice and easy to install and get configured. And what that would be is, for example, let's say you have this exact situation that we just showed here. You have a LAN and you have a guest network, and let's say you're at home, or let's say this is for a K-12 environment or a college, or whatever. Apple TVs are a very popular thing to have for screen sharing and media sharing and that kind of thing. So let's say you have a TV, and you've got an Apple TV hooked up to it, and you're on your local area network because your Apple TV is on your local area network, and you can connect to it, and everything is great, everything is fine. What you'll find is that if you have this guest network set up, and your guests come and connect to your network, that they may see the Apple TV sitting next to your TV, but they won't be able to find it. It's not going to show up in their list of devices. And why that is because the nature of Bonjour or Zeroconf, the very nature of that is the broadcasts are only done within that network. Okay, so there's no way, if you're on a different network, to receive those broadcasts. So Avahi to the rescue. I believe that's how you say it. I don't really know. But Avahi to the rescue. And what Avahi actually does is it runs on multiple interfaces on your pfSense server. It actually runs on way more things than the pfSense server, but in this case, it's a package that we can install. And it will run on multiple interfaces. And what it'll basically do is reflect Bonjour announcements and broadcasts. It will take those announcements and it will basically retransmit them onto other networks so that the other networks can, see and hear that, oh, there actually is an Apple TV on this network. It sort of tricks the service and makes it work because, like I said, the very nature of Bonjour is to be limited to the network and subnet that it's connected to. So I'll go ahead and show you how to do this right now, and it's actually a pretty easy process, which is really cool. Like I said, Avahi runs on many more things besides just pfSense. pfSense, and by no means did they create this service. You can actually just install any Linux distro you want and install Avahi on all the interfaces, and you'll be doing the same thing we're about to do here. But the cool thing is, with pfSense including this package, is that you already have a firewall running 24/7, presumably, and you already have interfaces connected to every single network. So it's kind of like the perfect fit to go ahead and run your Bonjour reflector on. Okay. So if we go here to Package Manager, Available Packages. Okay, and we just want to come down here to Avahi. All right, and here's the little description right here. Facilitates service discovery on local network via the MDNS protocol suite. This enables you to plug your laptop or computer into a network and instantly be able to view other people, chat, printers, whatever. MDNS reflection across LAN segments. This part right here is really what we're wanting to install this for. So that we can basically advertise our Apple TV on our local area network to other networks and make it usable to them. Okay, so it's a simple thing. You click on install and you confirm, and in just a few seconds it's probably going to be finished up. Okay, so you see right here it says, the package installation finished, everything went great, yay. So now what we want to do is go ahead and go to services, because the Avahi package is installed, but it's not running yet. It has to be configured before it will run, which again makes sense. Why run something before it's configured? So services, Avahi. And by the way, until you install Avahi, it doesn't show up here. Okay, so it automatically adds, the correct link where it's supposed to go. And you can see it is not enabled. Okay, so you can see that if we enable this and then we don't select any deny interfaces, that the Avahi service is basically going to reflect on all of our local interfaces. By default, it does not show any WAN interfaces. Okay, and that just totally makes sense. It would be a terrible, terrible idea to start broadcasting, Avahi announcements, or Bonjour announcements, and all that traffic out to the internet. It's a terrible idea. Okay, so it's by default only going to show local interfaces, and as you can see, we have LAN, guest network, and printer network, and those are the three LAN networks that we have. So we may want to say, you know what, don't worry about reflecting things to the printer network. We don't want any printers trying to do any Bonjour services. Of course, you may have printers that you do, and if so, then by all means, go ahead and set this up the way you would want. But for our purposes here, let's just say we have one Apple TV. We want our guests on the guest network to be able to connect to it, and that's it. So we would say, okay, we definitely want Avahi and the Bonjour proxy to run on LAN and guest network. So we'll leave those unchecked or unhighlighted because this is deny. Okay, and it says very clearly interfaces that you do not want Avahi to listen on. And there's also another note here. WAN is always disabled, so it's not shown here. That makes sense. Okay. So IPv4 enabled by default and IPv6 enabled by default. This disable dbus client API, I don't know exactly why you would want to turn this off, but I do know that from reading some things in the past, I do know that the dbus client API support for some reason was breaking connections or causing startup to fail for whatever reason, and so they decided to make it easy to turn off the API support. By default, it's not enabled, and we'll leave it unchecked. Okay, so let's go ahead and click enable so we don't forget that, and we are going to deny the printer network. And quite honestly, a lot of this other stuff you can pretty much just leave the way that it is. You may want to disable register a service type, a workstation. That's, if you're just dealing with like Apple devices or Apple TVs or whatever, they're not going to advertise, this workstation TCP. That's not a big deal. But for the most part, you can experiment with whatever devices that you're trying to use. It's going to depend on that. It's going to depend on what those devices need, and there may be things that you want to, make it more secure and come in here and maybe turn some of this stuff off if you don't need it. And there may be things that you need to turn on because your device requires. Okay, so the biggie right here is this enable reflector. If you turn this off, it's basically not going to reflect anything from one interface to the other. So make sure you have this turned on, and pretty much everything else is going to be good to go. And if you are just trying to reflect, an Apple TV or some sort of Apple device, from one network to the other, pretty much everything that you see that I've got, checked or unchecked is going to be fine. So we'll go ahead and hit save. And that's pretty much it. If you have other, VLANs and other networks, and it's running here, and you don't have them highlighted, then they'll be able to see the broadcasts and the announcements from the Bonjour devices. Now, I really need to make a point here because it's extremely important. Just because you're reflecting services from one interface to the other and making these announcements available doesn't mean that all the devices that can see the announcements will be able to connect to those services, and here's why. Bonjour and Avahi and the reflection is only making the announcements and telling the devices at what IP address these services are running on. Okay, so that's the first part. The second part is the firewall actually allowing the traffic to get from that IP address to the client that's requesting that. So that would be up to coming in here and looking at the firewall rules and basically saying, yes, I will allow this, or no, I won't. And there actually could be times where you may only want certain IP addresses on certain networks to have access. So that doesn't necessarily mean that that all of the clients on that network wouldn't be able to see that there's a service, but it does mean that you can limit who can actually connect. And so what would happen if the firewall was blocking the traffic is, let's say someone had an iPhone and they see an Apple TV they want to broadcast to, they would actually click to connect to the device, and it would eventually just time out after a few seconds and say unable to connect, unless you specifically come into the firewall and say basically this network can talk to these IP addresses on this network. And so you would just basically have to go in and configure your firewall and configure your rules to either allow or deny this traffic. It's very, very powerful, extremely powerful. But I want to make sure that people don't try to set this up and connect from one network to the other when they're not allowing traffic through the firewall from one network to the other. So you'll have to, for your environment and for your devices and your blocks of IP addresses that you're configuring on the LAN side, you'll have to figure out how best to set up your firewall and what traffic you want to allow to pass from one interface to the other. But definitely don't forget, check your firewall rules, and if you're having problems, and if you had the exact problem that I just said, that you can see the device but can't connect to it, check your firewall rules. And also, one thing I'm not 100% sure, but I've heard more and more about Apple products utilizing IPv6. And so you may, especially with Apple TVs and the latest iPhones, you may see a problem if you're not allowing IPv6 traffic to pass from one interface to the other. So that is pretty much it. If you go to status and go to services, you can see that the Avahi daemon is running, or the Avahi daemon is running. And you have some pretty cool options here. You can turn it off. You can just stop it and say, you know what, I don't want to broadcast my services to other networks anymore. Or you can restart the service if for whatever reason it hangs up or you have a problem. All right, and if it's stopped, it will tell you that it's stopped right here, so you can see the status of that. That is pretty much it. Once you get it set up and you go through the initial configuration page, it's a set it and forget it and it just works thing, and it's pretty cool. Like I said, don't forget your firewall rules, but once you set it up, it just works, and that's the way it's supposed to be. That's the way Bonjour and Apple have. That's the way they've tried to design it, so that there's, that's why it's also called, Zeroconf, because they just want people to be able to pull the devices out, see the device they want to connect to and click a button and they're done. So very, very cool. Now one thing I would like to do is, let's see. I was going to go into the VirtualBox and add network adapters and show you how to do it that way, but it really is the same as it's the same as what we did with the VLANs, except even easier. If you have more, if you have more physical network interfaces, you don't have to worry about creating the virtual interfaces. Let's see. You know what? We can do it real quick. We'll add one more device and show how to do this without creating a VLAN. So right here you can see I've got my VirtualBox running, and by the way, this is the virtual machine that we're connected to through the web interface right now. And so what I'll need to do is go ahead and shut the system down. Yes, I want to turn it off. And I can probably go ahead. And it's still going, still shutting down. It's a little slow, but to be a virtual machine running on old MacBook hardware, it's actually not too bad. So we'll go in here to Settings, and we'll go to Network. And as you can see, we've only got two interfaces assigned to this virtual machine right now, Adapter 1 and Adapter 2. They're both enabled, and they're both bridged. And they're connected to this MacBook's airport card. So if you go to Adapter 3, you'll see that we don't have it enabled, but it's very easy for us to come in here and turn this on. So we'll say yes, enable this, and we want it bridged just like the others, and we do want it connected to the Wi-Fi airport, and we'll hit OK. And start pfSense back up now that we've got this extra network card attached to it. And so basically, as far as pfSense is concerned, with what we just did, it was basically the same as shutting the server down, ripping the cover off, and throwing another network interface card into a PCI slot, for example, putting the cover back on, powering this thing up, and now we're going to see that we have another physical network interface card to work with. Even though we didn't do all that, it's kind of nice. We took a lot of work out, a lot of physical work out of the loop here by just doing this in a virtual machine. So it's all about saving work. Okay, all right. So you'll also see that now the console here actually shows all of our configured interfaces, and that's pretty cool because what you can actually do is now you can access these interfaces from the console as far as setting their IP addresses, running DHCP, whatever. You can actually come in here and turn those services on or off and actually call out these interfaces by name if you need to. Okay, so we're finished here with upgrading the server. Okay, so we just threw a new network card in our server. And we'll go back here to dashboard, and it's going to have me sign back in since it was rebooted. And if we go here to interfaces, you can see it's still not showing up right here yet because we haven't really created it as an interface yet. So if we go to interfaces and click assign, then now we see EM2 is now available. So we can assign it, we can do whatever we want. And we could, if we wanted to, we could go ahead and create more VLANs and assign these VLANs to EM2 so that we have, one WAN interface, one LAN interface with untagged traffic and 2 more VLANs on it. And then we could have a third interface. We can make it a LAN interface, and it could have, the same thing, or 10 VLANs. It doesn't matter. So we'll go back here. Let's say we don't want to do any VLANs on this interface at all. We just want to create a new network on it. So we'll say, okay, we'll come here. We'll call this the gaming network, IPv4, 10.0.220.1 with a 255.255.255.0 subnet, or /24. A lot easier just to say /24, and then we'll save it. All right, so let's just kind of make sure, gaming network 10.0.220.1 /24, done. Okay, so we'll apply those changes. And if we go here to interfaces and click assign, then we'll now see that our gaming network is up and running, and that it's actually the gaming network is actually running on a physical interface. Of course, we know not really, because this is running a virtual machine. But as far as pfSense is concerned, the gaming network and the 10.0.220.0/24 network is running on EM2, a real physical hardware NIC. Okay, so in the real world, if that were true, then this would be a port, an actual port on the server that you could plug into. Okay, so and that's a good way to look at it as well. Anytime you see EM0 or EM1, those are that'd be a physical port where you could plug the network into, connect the network cable into the server. So you can see here we have 3 networks, here, here, and here, all running on EM1. So you'll have one physical network cable being plugged into EM1, but 3 actual networks running on that, and that's where you get into virtual LANs, and that's the awesomeness of virtual LANs, is that the one cable can carry all of that traffic and keep it segregated the way it's supposed to be. Very powerful, very cool. VLANs, if you want to get into networking at all, VLANs are without a doubt something that you'll have to learn. I think we're really getting to the point where that's pretty much it as far as VLANs and proxying Bonjour traffic across VLANs or across interfaces. If I go here, let's go back to the Avahi service. You'll see that now it's even running on the gaming network. And if we didn't want it to run on the gaming network for whatever reason, we can just click on that one as well. And so, by the way, on a Mac, how you select more than one network here is you click the first one, and then you hold the command button and click the other one, and it will select multiple networks. And I think on Windows it's Control. Just click Control or push Control and then click, and it will actually select the multiple ones. So make sure that if you're running into issues and you can't get it to work for whatever reason, make sure that you don't have an extra deny interface selected that you actually want, and make sure your firewall rules are set up to allow communication from one IP address to the other. Okay. I think that's pretty much it. And if you have any questions or anything, just leave a comment below the video, and I will do my best to get back with you. Thanks a lot for watching.